Today we're going to continue looking at vectors and the geometry of space. Specifically, we're going to be looking at cylindrical and spherical coordinates. We're going to look at how to swap those coordinates from cylindrical to rectangular, vice versa. Same thing with spherical, and even cylindrical to spherical, and what those surfaces look like in space. Cylindrical coordinates are going to feel pretty familiar because they're basically your polar coordinates lifted off of the xy plane. I'll have r theta, the polar representation, and then we're going to have z, that's a directed distance off of that plane to point P somewhere in our 3D space. Looks something like this. You see that theta is still that angle opening up between the x-axis and r. Z value which will be given, and we'll not need any kind of conversion. We'll just lift it up into 3D space. Since we're talking about polar, I'll have x equal to r cos, y equal to r sine. Z will not need a conversion. It will just be the z value. We'll also still be able to talk about r squared equaling to x squared plus y squared, and of course tan of theta being y over x. 0, 0, 0 is our pole now that we're in 3D space. So if I have the point 4, 5 pi over 6, and 3, and I want to swap that over to rectangular coordinates, I can start backwards and see that z is going to be 3. There's no conversion there. R is 4, and theta is 5 pi over 6. This is in my second quadrant, so I'm going to start with my x. X is equal to 4 times the cosine of theta, which is 5 pi over 6. On my unit circle, so I can look up the exact value. If it's not on the unit circle, you'll have to use your calculator or some other way to estimate that value. Multiply, I get a negative 2 radical 3 for my x. Now do the same thing for y, 4 times sine of 5 pi over 6, and I have a 2. And z is still 3. And I'll be able to find that polar representation and then lift it up to 3, and I'm at the point negative 2 radical 3 to 3. So not a terribly hard conversion between cylindrical and rectangular coordinates. They're very helpful when we're looking at some of these different shapes. It'll also be a lot more helpful later on when we're doing triple or double integrals. Spherical coordinates are going to look a little bit more exciting, but they're really more of the same thing. There's just a couple of extra steps to them, and we're also going to get to see a few more Greek letters. The first part is going to be a distance, that essentially is going to be our radius, and then the second and third coordinates are both going to be angles. It's a little bit hard to wrap your mind around at first because we're talking spherical, so we're talking about the Earth's surface. And so you kind of have to think about almost warping some of the axes out. And so the first is our radius, easy enough to understand. And then my first angle, my second part of my coordinate, is going to be from this axis here. And then, so you can kind of think about that as spinning left, right. And then my second one is going to be along that z and up, down. So x, how far are you going out? Y, we're going to spin this way. And then z is going to be another axis up and down. My x is now rho, this fancy looking p. It's the distance between p and the origin. Rho is going to have to be greater than or equal to 0, right? It can't be negative. Theta, that's the same from the cylindrical coordinate, so it's still that y value. What's a little bit different here is phi or phi, depending on how you choose to pronounce it. And it is the angle between the z-axis and that line segment from the origin to P. And phi is going to be between 0 and pi inclusive. First and third, non-negative. The second, theta, can be a negative angle. X is going to be rho times the sine of phi times the cos of theta. Y, rho times sine of theta, sine of phi. I'm sorry I swapped those, but multiplication, so either order is fine. So you can still see that you have the polar coordinates wedged in there, except now instead of r, we're using rho, and I have the sine of phi wedged in there. Z is not Z anymore. Z is now rho, or almost like our old R, if you will, and cosine of phi. Rho squared is x squared plus y squared equal to z squared. Tan of theta is still yx. Now I'm going to have a third one that goes back to those directional cosines that you looked at earlier in this section, and the arc cos of z over the square root of basically rho squared. So you're talking almost like your magnitude, right? X squared plus y squared equal to z plus z squared. Take the square root of that. And then what's that distance? And then you'll be able to get that angle. Phi is going to be the directional angle from z to there. I'll have r squared is equal to rho squared sine of phi squared. Theta is theta. So we won't have a swap there if we're going from spherical to cylindrical. And z is going to be rho cos of phi. If I'm going the other way from cylindrical to spherical, I got rho is the square root of r squared plus z squared. Theta is still theta. And my phi is going to be that directional cosine. Before we look at how to sketch some of these and swap equations, let's do some practice with switching coordinates. So I have a cylindrical coordinate of 6, negative pi over 4, 6. So I have r being 6. Theta is a negative pi over 4. And of course z is going to be a 6. So if I want to go to rectangular, I have x is equal to r cosine of theta. And y is equal to r sine of theta. Z is just z. So z is going to be 6. Y is going to be 6 times the sine of a negative pi over 4. This is on my unit circle. Negative pi over 4 is going to be a negative radical 2 over 2. And so we're talking about a y coordinate of a negative 3 radical 2. X is equal to 6 for r times the cosine of the negative pi over 4, which is going to be a positive radical 2 over 2. And so my x is going to be a positive 3 radical 2, and I have my points swapped over. If I have rectangular coordinates to spherical coordinates, then I want to go to rho, theta, and phi. And now I know phi looks like this usually, something like that, kind of almost like a theta. And WebAssign, they tend to write it like this. So I have x is equal to 7, y is equal to 7, and my z is a 2 radical 5. Let's get our formulas and pull them over so that we can remember. Well, I want rho. I have rho squared. So how about rho being the square root of x squared plus y squared plus z squared. And so I'll have, what's that, a square root of 98 plus a 20, so the square root of 118. That would be rho. Theta, well, tan of theta is y over x. And so I have y, and I have x, 7 over 7, so that's a 1. What angle has the tangent of a 1? That is going to be pi over 4. And so I'm going to put a pi over 4 in here. And then z. Okay, so I have z. That is 2 radical 5 over the square root, which I have conveniently found, of x squared plus y squared plus z squared. So that is the square root of a 118. And I need the arc cos of that. What angle has that cosine? More often written like that. And I want it in radian, but it's going to be easier to kind of wrap your mind around if you have it in degree. So I'm going to change this over to degree. I'm going to say what angle has the cosine of 2 radical 5 over a radical 118. At a 65.7. So let's see if I want to change this. Let's say 66 degrees, and I want to change that over to radian. And so I'm going to need a 180 down here and multiply times pi there. So 66 divided by 180 is about that. About 11 over 30, so I'm going to say 11 pi over 30. Now they didn't tell me where to round here, I just kind of picked a spot to round, so it may want it just written as a arc cos of 2 radical 5 over the radical 118, since it didn't say round to or anything like that. They may want the exact form. Let's go the other way. I got spherical. I want to go back to rectangular. So I have rho being 8. I have theta being a pi over 6. And then phi is going to be pi over 4. Let's see. Let's go the other way and see what we wind up with. Well, x is equal to rho times the sine of phi times the cosine of pi over 6. Y, pretty similar, 8 sine of phi sine of pi over 6. And then finally, z is going to be my rho times the cosine of pi over 4. Now I remember the pi over 4s. Those are all going to be radical 2 over 2s. But that pi over 6, oops, I always swap. So I'm going to pull up my unit circle. And see what I have for pi over 6. Cos is radical 3 over 2. So that makes this a 1/2. And so how about x being a 2 radical 6, y equaling a 2 radical 2, and then z, that's not really there, a 4 radical 2. Let's start looking at maybe swapping some of our equations. We looked at 1 for, or 2 for swapping between rectangular and cylindrical, but we haven't looked at spherical. So I have an equation in rectangular, x squared plus y squared minus an 8z squared equal to 0. Now what we want to do is find this over in spherical coordinates. So I want to take out x, y's, and z's, and I want this all written in forms of rho and arcoses like that. Let's pull up some of our conversions. Let's see, rectangular to spherical. Let's see what we have here. Well, you can see that we almost have rho squared. The problem is that I have this negative 8z squared. I would really prefer that it were just a positive z squared. So we're going to kind of make it that way. Another way to say negative 8 would be a, how about a positive z squared minus 9z squared, right? So if I put those two back together, I would have negative 8z squared. equal to 0. So now I actually have my rho squared. And I'm going to move the 9z squared over to the other side. So I have now a positive. And then I have z squared over here. Well, let's see. Z is also known as rho cos of phi. And so z squared would be rho squared cos of phi squared. And then I have multiple phis here. I can divide those out. So I'll divide both sides by, rho squared. So I'll have 1 equal to 9 cosine phi squared. And I can actually move over that 9 too. Now this looks pretty good the way that it is, other than my phis have morphed into thetas. But we can take the square root, and if I take the square root of both sides, I have the square root of 1/9. So a positive or negative 1/3 is equal to cosine of phi. And so something looks like this. If I'm talking about cosine of phi, I'm actually talking about a cone. So I have something going on like that. All the spots, like if you can imagine swinging this around, that the cosine of the angle between z and that would always be a 1/3. And so I'm talking about something of a cylindrical equation. Two other ones that we can look at in here. This has a little bit of a piece missing. Should be a 0. So I have a cone. That's an x squared plus a y squared equal to z squared. I'm going to put a 0 in there. And then a sphere that would look something like this. We're going to use all our swaps to take our rectangular over to spherical. And so I have x squared plus y squared equal to a z squared. So x squared plus y squared, well, I know what x is. X is rho sine phi cos theta. And y is rho sine phi sine theta. And then we just used the z before, rho cos of phi, and square everybody out. On the left, I'm going to be able to factor out a rho squared sine of phi squared. And cos squared of theta plus sine squared of theta is good news because that's a 1. So that pretty much just will go away. And I got rho squared sine phi, and that's equal to rho squared of cos squared of phi. And I can divide out the phi squareds and move over my cosine, and I got a tangent of phi squared. And I want to know, well, if I take the square root of that, I'm talking about all the places that tangent is equal to a positive or a negative 1. So that's going to be at all of the pi over 4s. And we'll have our cone again. A sphere, if I have the x squared plus y squared and the z squared, just to remind you, it was x squared plus y squared plus z squared minus a 4z. I have rho right here, so I'm going to be able to take that piece out. And then my extra z right in here is rho cos of phi. Factor out a phi, and I have something that's a quadratic. So I'm going to be able to go through both of these and look at all the different places that we can have this happen. Whereas 4 of cos of phi equal to a rho, and I'll have my sphere. And so there's lots of different small steps, but they're not entirely new steps to switch between rectangular, cylindrical, and spherical.